NOR relation. Okay, try to take out the first one. So as usual, NOT gate. NOT means what? You need to have like if I'm going to give input A as input, you need to have the output as A complement. A complement, right? See, NOR means it is going to take two inputs and trying to perform OR operation over it and trying to perform complement. This is what the meaning of NOR, right? Meaning that if I'm going to give X and X as input, assume you are going to get X plus X whole complement. What is X plus X whole complement? X plus X is what? X only, again complement. So are you going to get that or? If you are going to give A as input, you are going to get A complement. If you are going to have X as input, you are going to get X complement input, right? Which is equivalent to X, you are going to get X complement. So NOT gate I can able to represent either in the form of NOR gate or either in the form of NAND gate, right? That's why I'm calling it as universal gates. Similarly, take out the AND gate. AND gate, right? See guys, AND gate means what? AB. If I'm going to give the two inputs AB, I need to get the output as uh, AB only, right? So try to take out double complement, AB whole complement, and trying to take the double complement, there is no problem. So A complement plus B complement whole complement, right? So guys, you know how to get the complement. You know how to get the complement uh, for A. You know how to get the complement for B, right? And you got plus, and then you have the complement, right? So this I can call it as, assume that this is as X, this as Y, this as Y. X plus Y whole complement, it is in terms of X plus Y whole complement. If it is X plus Y whole complement, can I do it with the NOR operator or not? Yes. So that's the reason I will try to do, right? What is A complement? How can I do that? If I'm going to have A as input, I will try to take it in the form of NAND gate. If I have B as input, I will try to take it in the form of NAND gate, right? I got A complement and B complement. Now for this I need to perform OR operation. For that I have to go with the complement operation. So you can take one more NOR operator. That's it. So this will yield to AB as output. Third one, OR gate. OR gate means if I am going to have two inputs AB, I need to get the output as A plus B. Get the output as A plus B, right? So guys, if I am going to give two inputs AB, if I am performing simply OR operation, I am going to get A plus B. But if I am going to have complement, what you are going to get? A plus B whole complement. For this, if I am going to remove simply this complement, will you get A plus B or not? Yes. That's why I am going to give certain again uh, to the complement, A plus B whole complement whole complement. So are you going to get A plus B or not? Yes. Okay. Next, we'll see uh, X OR gate or XNOR gate, whatever it may be. You can do, you can take. Uh, but the thing is, from one, if we are able to do, you can get the another one, right? So I will try to do it with XR gate. XR gate, right? What is XR? XR means A bar B plus B bar A. B bar A, right? So here to get the XR gate, so as earlier side example, I will try to add two values A bar plus B bar. Is it a problem? Nothing, right? From this I am going to take out the common A bar plus B bar plus A into A bar plus B bar, A bar plus B bar, right? Earlier I required to represent in the form of sum of products because it is NAND relation. Now to represent this in the form of OR gate, it requires OR and gate relation. See, or and gate. So that's why or and gate means what? That should be compulsory product of sum, right? So I am trying to like this: a complement plus b complement into a plus b. Is there any problem? No, nothing. So now for this, I am trying to do some kind of complement again, double complement. If I do double complement, you are going to get one complement. That inner complement I am going to distribute a bar plus b bar plus b plus a whole, b plus a whole. That's it, right? Now observe, this is like see, a complement you get easily using XR, B complement you can get easily XR. This entire terminal you are going to get with XR because it is in the form of one NOT gate. This is in the form of one NOT gate you can get. Okay, and this is OR operation. For this operation, complement is excuse me. OR operation with complement is uh, XR only, right? So I will try to construct the circuit for this. Try to do first. I will try to do a plus b whole complement, right? So if I am going to have two inputs, a, b as two inputs, for this I am trying to get a plus b, and to get the a plus b complement I am trying to do this. So you got a plus b whole complement. Okay, now I need to get a complement and b complement as well, right? So to get the a complement I am going to use one XR. Once again you will get a complement, and I am trying to use b complement. For that XR is used. So here I will get a complement, here you will get b complement, and I am trying to perform some operation over it, some operation I did. For that some operation there will be whole complement. So again XR. So you got this term as well as this term. Now try to perform OR operation. If I am trying to perform OR operation, I will get like this. But the thing is, there is a whole complement. So in order to represent XR using NOR gate, how many gates are required? 4 NOR gates are required. 4 NOR gates are required. Okay, fine. See, if I take the XR, see, these are how many? I think 5, right? 1, 2, 3, 4, 5. 5 NOR gates are required. Okay, fine. See, the same representation we can represent in another form, right? This is the common thing you can observe in various kind of textbooks. That's why I'm going to redraw the structure. A, B as input, this is one NOR gate and another NOR gate. For this input I'm going to get like this, and for this input I'm going to get like this. So this is also A XOR BM, XOR, right? These two are same, right? If you are going to give the inputs, you are going to get the same outputs for these circuits. Okay, fine. Let us see the next one, XNOR. Okay, XNOR means what? A bar B bar or AB, right? So guys, so try to do here. I am trying to make something in the form of like uh, this is like XNOR, right? Okay, so how can I derive this? So like I'll try to do. So can I write like this a bar b bar plus ab as a XOR b whole complement? Is it correct? Yes, right? Meaning that for XNOR, if you want to get, that is what I said, right? For XNOR, if you want to get, you can able to just add one more complement. Just add one more complement. You are going to get a XOR b or not. Or if you remove this one, this particular part, you are going to get the exact thing XNOR. So I will try to do that, right? So I'm going to write. So this one, I will write it as a bar b plus a b bar. Right? So try to do like I will try to so instead of writing like this continuously, I will write as a bar b plus a b bar, as earlier I have written a bar b bar whole complement. I will try to take out the common as a complement. If I try to take out the a complement, that is a plus b. If I try to take out the b complement, that is again you are going to get a plus b. Guys, earlier procedure only I am doing, right? Now what I will do now, instead of writing like this, I will try to modify it in product of sums. uh, what I will do, I will simply, this complement should be same, and I will try to make it double complement. When I make it double complement, you are going to get, see, uh, do again double complement. Then you are going to get a bar into a plus b plus b bar into a plus b. Okay, fine. Now try to distribute this. Or else I will write to chalo. You can write this equation, or else see, I will try to take a complement into a plus b whole complement. Can I do? Yes. B complement into a plus b whole complement whole complement whole complement, right? If I try to combine these two as one, then are you going to get a plus b whole complement and the whole complement. If you are going to do the formula, right? So if you try to remove this like complement, you will get a complement dot a plus b whole complement, right? That's why I have written the syntax like this, right? Plus b plus a plus b whole complement whole complement for this between the plus is there, right? Now try to observe. This is one expression, finally complement form. This is x plus y whole complement. That's the reason I have taken like that. Okay, so now try to represent the same circuit. So first I will try to do uh, the a plus b whole complement. A plus b whole complement, if you are going to do a b a plus b whole complement, right? For that you have to take 1a and you have to apply one second complement. So the first expression is done. And for b you have to take I think this input you have to take I am trying to take, so you are going to get b plus a plus b whole complement, a plus b whole complement. For the both you have to do again. So I got x and I got y. I need to perform complement operation. Guys, this should be XOR, right? Finally, we are going to get a XOR with b, right? So in order to implement XNOR, how many NOR gates are required? 4 NOR gates are required. 4 NOR gates, right? But in the industry or in some set textbooks, you'll observe this kind of syntax, this kind of circuit, right? This circuit will be parallelly written as like this. So now if I'm going to have the input a and b, here we are going to get what? A plus b whole complement, a plus b whole complement. Okay, this input I am trying to give as one expression, b plus a plus b whole bar you got. Now the same input I am going to give for one more thing, that is a plus b bar whole bar I got. For this I am trying to get, so this is also a XOR b, okay. I hope understood clearly, right? So means if you would like to construct, uh, XNOR gate using NOR gate, you require 4 NOR gates. 4 NOR gates, right? If you would like to construct the same XNOR with NAND, how many gates are required? 5 gates are required. You have to remember, this is important. If you would like to implement XOR gate with NAND, you require 4 NAND gates are required. This is like NAND only. If you would like to implement the same XOR with NOR, 5 NOR gates are required. I hope understood clear, right? Now if you are able to observe, with the help of NOR gate, I can able to construct NOT and OR, XOR as well as XNOR. So this also called as a universal gate. Right? So you can observe here, right? So if you are going to get any kind of circuit, you can simply construct that circuit with the help of either completely NAND gate or completely NOR gate. So company won't have any problem. They'll simply construct or they will simply produce either NAND gates or NOR gates. They won't bother about how many AND gates required, OR gates required, like that. Right? That's the simple thing. That is what the advantage of universal gates.